But if you have an element within a chemical reaction and you just list it, give me an example. You guys have your balancing assignment in front of you. Which one of those, as we go down through that assignment, which one, the first one for example, let's go do the second one. Okay, so I'm going to use this as an example of elements by themselves will be listed as 0. Okay? And so when we look at the second one, it's the one, it's Al, isn't it? Plus PbCl4. Reactions, a lot of reactions, the electrons move from a place that they don't really need to be to a place that really wants them. So a lot of times reactions will go from like, hey, you're on that team. Why don't you come on our team? We'll use you. We'll value you. That other team, they don't value you. You never play. You are, they're not included in a lot of things. And that's like electrons. Electrons are like, hey, I'm not going to stay here. I'm going to go over there where I'm wanted. Okay? So this aluminum would be a 0 charge. Does that make sense? Or a 0 oxidation state. I use charge way too often. This one would be a 0. Okay?
Just because they're alone?
Just because they're alone. Now, if you see Al as a +3, what's this oxidation state?
3.
+3. Okay? So if an element's neutral and by itself, it hasn't lost or gained any electrons, its value is 0. Make sense? Okay. Now we'll come back to this maybe, just to kind of show what's going on with these electrons. But for right now, we're going to leave this thought and just realize, I'll give you some more examples real quick underneath this. All right? F2, that would be 0. Okay? Sodium, 0. So I think you get the drift of it. Ozone, O3, 0.
So it's
Okay.
only if they have a plus or minus on the top. Right?
Okay. If you only see one element and you don't see a charge, it's always 0. Yeah, even if there's 3 subscript, 2 subscript, there's some that could be 8 subscript below it, like sulfur I think can be S8 because it's an allotrope. We don't get into that. Yeah, they're by themselves or 0. Okay? Now, second one. Hey, you don't have to write this one down if you want to, you can. But the second one just says, whatever the charge is, that's what we represent as the oxidation state. So, ionic compounds you treat just like you always have. You just like, hey, I'm going to look that charge up, find that charge. But they're also oxidation states. Oxidation states encompass a lot more, or basically every type of compound. Not ionic, but every type of compound. So, ionic compounds you treat exactly like you always have. All right?
We don't go yet,
I won't. So, like, you go CaCl2, and you go, oh, calcium is a +2 oxidation state or charge, and chlorine is a -1 oxidation state or charge. Okay? Doesn't change any. All right, so that part you know. You've got that down really good. And that first part, you probably know that one really good too, because that's pretty easy to remember. Something by itself, it's 0. And we do it just to kind of see where electrons go. So, we go back up to here and go, okay, let's find charges. What's the charge of chlorine?
4. Right?
Overall charge is 4, but what's the individual charge? -1. Which would be a -4, so what's Pb? 4. Okay, see that? Now I'm not putting the total charge down. I am just assigning the charge for every single element of those 4. Each one of those 4 is a -1. And then plus 3 minus 1. You tell me, what did aluminum do? What happened to aluminum when it went from the left to the right side? It now is a positive free. How can atoms get to be positive? What do they have to do? Get rid of electrons. How many did it get rid of? 3. Now, if it gets rid of it, something has to pull it in. So which one pulled in the electron? Pb. But it has to pull in 4. And aluminum only has 3 to give up. So you guys see why we balance? Because when we balance, those electrons will equal out. We're not going to get into that now. Okay? Okay? This is called an oxidation reduction reaction. And a lot of reactions are rusting, iron rusting, oxidation reduction reaction. Okay? If something iron rusts, it loses electrons and now becomes brittle because it combines with oxygen. It's no good anymore. Yeah. It's no good for making anything strong, sturdy. Okay. This is the big one that's new. Now, I put 2 keys on here that you need to be aware of. Fluorine is always a -1, no matter what. 100% of the time, if fluorine is present, it is assigned a -1.
Wait, what's the first word? Bird?
Binary.
That's an A, not an R.
Binary. Binary. That's okay. Binary. But you guys know what binary molecular would be. So, fluorine's always a -1. If H is kind of different. H, hey, if it's with the nonmetals, it's +1. But when it's with metals, it's a -1.
So do you want to just write H as a +1?
When with nonmetals.
Okay.
You write it however you want, but you need to include that it's a -1 when it's placed with metals. So you probably know those people, they act one way around certain people, and then they act a different way around other people. Hydrogen's kind of like that. Hydrogen said, hey, I'll be a +1 with you guys, but when I get with those guys, I'm going to be a -1. And so that's usually the way it goes. For what we do, hydrogen is pretty much a +1 all the time. Very rarely do we see it take on a -1 characteristic. So everything that we do in here, it's what makes chemistry tough. There's these little rules you have to remember, and some people don't like remembering, or they forget them, or whatever the case might be. All right, now this next part, I don't know how to maybe state it the best, and it's probably best if I show you examples. So why don't you wait to write this out if you don't understand the examples, okay? So this next part, don't write it out. And then if you feel like you need to write it out, just wait. Write it out. And then you can go back to it if you need to. So, we got a binary molecular compound, P2O5. Let's look at what it says. The higher electronegativity of the 2 elements bonded will take on a negative oxidation state, similar to ionic compounds. So P and O, which one's a higher electronegativity? You look on your periodic table, it's in front of you, and you look on the back, and you find that oxygen is a -3.44. You look at phosphorus, it's not a negative, and phosphorus is a 2.19. You go, oh, oxygen has a higher electronegativity, so what's its value? -2. Which makes it a -10 total. So phosphorus, it says, the first nonmetal, oxidation state, which is going to be positive, will be determined by the oxidation of the second element, like always. So what's phosphorus oxidation state? Okay, now, normally, if phosphorus is in an ionic compound, what oxidation state is it? Negative what? -3. And you're saying, well, why isn't the -3 here? Because we got two nonmetals battling for the electrons. Guess which one wins out? Oxygen. Oxygen has the electrons. Phosphorus doesn't. So phosphorus takes on a +5. Because they've got to balance out to 0. Okay? I'm going to give you two to do. NO2 and S2O6. So do those two. NO2, S2O6.
How did you get the,
How do you get to 2?
Which one?
yeah, I'm a little confused on that too.
So you did P2O5, right? And then O, it has the higher
Yep.
electronegativity.
Yep.
And then you got 2 somehow. Where did you get the 2 from?
Is that the,
So
Sure.
why do we use the 2 for that 2 for the oxygen?
This -2?
Yeah, like I understand how you got like the negative and like
Right.
that, but I don't get why the 2. Why wouldn't you use the 5? Like I don't get it.
Okay? So the deal is, like always, we've got to get this to be 0. And so the rule says the one that you assign a -2 would be the higher electronegativity. Oxygen is the higher of the two. So I assign oxygen a -2. There's 5 of them, right? So that's a -10 total. The question is, now I've got to find this oxidation state, we call it, for phosphorus. The only thing it can be is a +5.
So you're basically just switching.
Kind of, yes. I would not get, maybe, that's not a foolproof thing, the switching part of it, because you can have smaller ratios. It's pretty much like we've always done, but now some of our nonmetals are positive charge. Okay? So, on NO2, -2, -4, what does nitrogen have to be?
+4.
+4. Okay, is there a +4 there for nitrogen? Sure is. +4.
Oh, there is. Okay, I see what you
Now those other values kind of come in. So now we're talking nonmetals. Now those other numbers are coming in, like, well, when do we ever use those? Now, go ahead and do the second one. S2O6.
so is it always -2?
Unless it's paired with fluorine. And then it won't be a -2.
So,
So pretty much oxygen's always a -2 unless you pair it with fluorine. Which, how often do you see that?
only oxygen?
No, look.
I am so confused.
Okay,
So my cells are choking.
so what are you confused about?
So, do like all the elements, let's say you were gonna have N and something else,
Yeah.
would it still be -2 for the second element?
For oxygen?
No, for the second element, let's say it
No.
wasn't oxygen.
Second element takes on the charge, whatever it is on the periodic table.
So that's
Okay.
higher.
Yep.
So you look at the higher one.
There's just a lot of oxygen involved in these.
And you look at, then you look at charge, the higher one's charge.
Okay? So this would
And
be
then you have to
-12 total, right?
And then you have to times that by
So what's the sulfur have to be?
and then you have to
6.
find out
+6.
Wow,
2
right.
times
Okay? So then you look on there and you say sulfur, yep, it can be a +6.
How do we know if it can?
because you have to equal them out.
It won't be on here.
And to make sure it's correct, it has to be.
Look at your periodic table, find sulfur, and there's some other charges that are on there. Oxidation states
Why
that
do
are
we
on
have
there.
to know this? Like, why can't we just look on the periodic table like we've been doing?
Because there's multiple, you don't know which one's correct.
So normally you assign sulfur what value? You should, because you did the test where you -2. So now it's no longer -2. What's that?
That would be wrong, because then they wouldn't balance.
Right. So we've got these nonmetals hooked together, and we cannot assign like we normally do. That's
This
why.
is only for the non-metals.
What's that?
This is only for the non-metals.
Yep.
Oh, okay.
Yep. Okay. Last one. Okay. This one is again. You don't have to write this down because polyatomic ions work the same as binary molecular. So if I got a polyatomic ion, I'm going to use the same reasoning as I did for the binary molecular. But what's the difference?
There's 4
what's at the end? Instead of equaling 0, it's going to equal the charge. So I'm going to put up this, I'm going to put phosphate up here. It has a -3 charge. So instead of adding everything up to be 0, like binary molecular, this one's going to equal the charge. So then we go, okay, oxygen's a -2. Got 4 of them. That's a -8. What's the charge of phosphorus?
Plus 5.
+5. You see that?
Yeah.
Okay, so they have to equal the charge. I'm going to give you another one. BrO3 equals a -1.
Plus 5.
Okay, +5, because this is a -6 total. I'm just putting the total, I'm not doing the math. This has to be a +5 to get to be a -1. How about CO3, carbonate? See, these are all nonmetals hooked together.
Plus 1.
So this would be a -6 total, so what plus a -6 gives you a -2? Plus 4.
Yeah.
Okay? So, what's new and different, what we've done, is the first one, if they're by themselves, they're 0. And if we got nonmetals hooked together, then one of the nonmetals is going to be a positive, where normally when it was ionic compounds it would be negative. And you use the one with the higher electronegativity, which is usually the second one listed. I'm not going to say it all the time, because here's one case where it's wrong to do it that way. So we look up NH3. Okay? So, but hydrogen is going to be what with a nonmetal? What's the rule?
R plus 1.
+1. And I got 3 of them, so that's a +3. And so nitrogen is going to be what? -3. Why do you think they don't put H3 in? So why wouldn't, normally we have H in front and it's positive when we put it in front, H3 in. What does that tell you about that substance?
On acid.
It's an acid, but ammonia is a base. So they don't put the H in front because then they would think, hey, that's an acid and ammonia is basic. Okay? You guys will get to practice this. Yes?
Can I ask a question?
Yep.
How do you know if it's polyatomic or binary?
They'll have this.
It'll be off your sheet.
Oh, they'll be on the
Polyatomic ion sheet.
Okay.
These
So you
are,
just have to-
yeah, plus it'd be charged. They're charged.
They'll show the
They'll show the charge. -1, -3, -2. Yep. Okay? If they're binary, they won't show a charge.
Okay. That makes sense, I guess.
Yeah. Binary won't show a charge. Okay. What we're going to do... Okay, next on page 498, 6 through 9 and 14. 6 through 9 and 14. You get out in about 5 minutes. 52.